Hi class 9 students, I hope everyone is doing well. So this is our lesson number 2 of the chapter Structure of the Atom. So guys, we will continue the lesson number 1 and here we will discuss about canal rays, protons and their characteristics. Now let us see. E. Goldstein discovered the presence of new radiations in a gas discharge and called them canal rays. Now let us see what are canal rays. So it is a beam of positive ions which is created by certain types of gas discharge tubes. Alright, so canal rays are positively charged radiations and this is the scientist Eugen Goldstein. Now let us see, this subatomic particle had a charge equal in magnitude but opposite in sign to that of the electron. So this subatomic particle, we already got to know that they were positively charged radiations. Now they are equal in magnitude but opposite in sign to that of the electron. Its mass was approximately 2000 times as that of the electron. So this subatomic particle, its mass was approximately 2000 times as that of the electron. It was given the name of proton. So that subatomic particle was named as proton. Now proton, it is represented as small letter p. Alright. Now see the characteristics of a proton. The two important characteristics of a proton are its mass and charge. So mass and charge are the two important characteristics of a proton. Now let us see the mass of a proton. The proton is actually a hydrogen atom which has lost its electron. Now you might be thinking that why is a hydrogen atom called a proton, right? So let me explain you. A hydrogen ion is formed when a hydrogen atom loses an electron, right? And therefore becomes positively charged. That means it has a charge of +1. So a hydrogen atom is therefore often referred to as just a proton, as it is left with only one proton and no electrons. So as a hydrogen atom only has one of each. Clear everyone? The relative mass of a proton is 1U. So 1U, it is the relative mass of a proton. Now let us see the charge of a proton. The charge of a proton is equal and opposite to the charge of an electron. So the charge of a proton is equal and opposite to that of an electron. So proton, it has positively charged, whereas electron, it is negatively charged. So the absolute charge of a proton is 1.6 into 10 to the power minus 19 coulomb of positive charge. So 1.6 into 10 to the power minus 19 coulomb is the absolute charge of a proton. In other words, the relative charge of a proton is +1. So +1, it is the relative charge of a proton. Now let us see Rutherford's gold foil experiment and its drawback. This is the scientist Ernest Rutherford. He was born at Spring Grove on 30th August 1871. He was known as the father of nuclear physics. So Rutherford was known as the father of nuclear physics. He is famous for his work on radioactivity and the discovery of the nucleus of an atom with the gold foil experiment. So Rutherford is famous for his work on radioactivity and he also discovered the nucleus of an atom with the gold foil experiment. He got a Nobel Prize in Chemistry in 1908. Now let us see Rutherford's model of an atom. Ernest Rutherford was interested in knowing how the electrons are arranged within an atom. So Rutherford was very interested to know how the electrons are arranged within an atom. So Rutherford designed an experiment for this. Now in this experiment, fast-moving alpha particles were made to fall on a thin gold foil. Now let us see what are the alpha particles. So alpha particles is a positively charged particle having 2 units of positive charge and 4 units of mass. So alpha particle, which is a positively charged particle, and they have 2 units of positive charge and 4 units of mass. Now let us see the gold foil experiment. Take a source of alpha rays. So this is a source of alpha rays. Now what are alpha rays? They are beam of positively charged particle. So alpha rays, they are beam of positively charged particle. Now in front of the source, keep a thin gold foil. So in front of this source, keep this thin gold foil. Now what is a gold foil? It is a thin sheet made up of gold. So this is a thin sheet which is made up of gold. Then keep the screens so that it can detect the alpha rays. Now as you can see here, the first alpha ray passes through the gold seed, right? So now let's see the reason behind this by performing a simple experiment. Now stand near a fence and throw a stone towards the fence. Alright, so here the stone passes through the fence to the other side, right? So why does this happen? Yes, it is a simple answer. There is a lot of empty space between the two planks of the fence. Hence the stone passes through the fence. As you can see here, there is a lot of empty space between the two planks of the fence. So easily the stone can passes through the fence. Similarly, in the gold atom, there is a lot of empty space from where the alpha rays passes. Similarly, here in the gold atom, there is a lot of empty space from where the alpha rays passes. Alright, then see here, the second ray hits the gold foil and turns back. But here the second ray, it hits the gold foil and then turns back. So now let's see the reason behind this. Here, as you can see here, the second stone hits the fence and turns back, right? So similarly here, the second ray hits the gold foil and turns back. So now in this case, why does this happens? So you can say that this happens because the stone hits the plank and does not allow the stone to pass through. But this time the stone, it hits the plank and thus it does not allow the stone to pass through. So similarly in the gold atom, there is a positively charged part which turns the positively charged alpha rays. So similarly in the gold atom, there is a positively charged part which turns the positively charged alpha rays. Clear everyone? So now see here, as you can see, some rays are turning back while some rays are passing through the gold foil. So now majority of the rays passes through the gold seed. Can you see it? Majority of the rays, it passes through the gold seed. So now this shows that the part from which the positively charged alpha rays turns back is very small in size compared to the empty space. Conclusion of Rutherford's alpha particle scattering experiment show the presence of a nucleus in the atom. So in the conclusion of Rutherford's alpha particle scattering experiment show that there is a presence of a nucleus in the atom. It also given the following important information about the nucleus of an atom. First one, nucleus of an atom is positively charged. So the nucleus of an atom, it is positively charged. Nucleus of an atom is very dense and hard. So the nucleus of an atom, it is very dense and hard. Nucleus of an atom is very small as compared to the size of the atom as a whole. Now the nucleus of an atom, it is very small as compared to the size of the atom. Here the radius of nucleus has been found to be about 10 to the power 5 times smaller than the radius of the atom. So it is, the nucleus is 10 to the power 5 times smaller than the radius of the atom. Now see here, the relative size of the nucleus in an atom is roughly the same as that of a pea in the middle of this large stadium. So consider this pea. So we can imagine that the size of the nucleus in an atom is roughly the same as that of a pea in the middle of this large stadium. Alright, clear everyone? So now see the drawback of Rutherford's model of the atom. So the major drawback of Rutherford's model of the atom is that it does not explain the stability of the atom. So Rutherford's model could not explain the stability of the atom. Any particle in a circular orbit would undergo acceleration. So this electron which is in the circular orbit, it would undergo acceleration. Now during acceleration, such particles would radiate energy. So this electron, it would radiate energy during acceleration. Now thus the revolving electron would lose energy and finally fall into the nucleus. Thus the revolving electron, it would lose energy and then it finally falls into the nucleus. Okay, so this is the positively charged nucleus. If this were so, the atom would be highly unstable and hence matter would not exist in the form that we know. Now, if this were so, then the atom, it would be highly unstable and hence matter would not exist in the form that we know. And we know that atoms are quite stable.